Hello, today is Thursday, September 3rd, 2020. My name is Daniel Mullany, and behind the camera is Caitlin Yates. Today we are filming a video source inspection for Scitech Process Solutions. Today we are reviewing a fully refurbished Fluoroware HTC 8030 box washer. This system was sent in from a customer for a refurbishment, and their PO number is C5655002.00. So today we're going to be viewing this fully refurbished HTC 8030. This 8030 was sent in for refurbishment by our customer after many years of operation in their fab. It arrived from their fab in a fairly poor condition, not from upkeep, but just from general use over many, many years. This system has, from what we can observe, had hundreds of hours of runtime and has now been revitalized and is ready for several hundred more, if not thousands. So this system had a refurbishment specification on it for many parts to be replaced, many parts that were inspected and cleaned up and replaced as needed, some parts that were rebuilt, and other parts that were inspected and cleaned. So we had a few different categories of how we treated this system, and as I go through it, we'll describe which parts were replaced, which were treated, changed out, and otherwise. So the first thing that I will do is, actually before we get to the front of the tool, I'll kind of come to the side of it. Here we have the high voltage power box here, and we're a little tight on space here, so the camera's stationary. We'll do our best. But we have their high voltage power box here. The high voltage power box was inspected for all wiring layouts and all the wiring components, all the electrical components, ohmed out, tested to ensure they are within normal operating function. Throughout that process, we had to replace two of the contactors, and we also had to rewire the power box slightly. There were some jumpers and otherwise that were non-standard, but the power box has now been returned to standard and is in a normal electrical configuration, works properly. From here, I can see to the back of the tool that we have a surfactant tank. This surfactant tank was replaced and now has the float sensor. The previous surfactant tank did not have a float sensor, so we now have that float sensor wired into the controller to ensure that proper levels of surfactant are maintained during operation. I'm now coming back to this side of the system. From here, I can see several more components that I'll describe. First, we have all of the pneumatic tubing. That was all replaced. The pneumatic tubing is associated with the solenoid bank that operates the air knives. All of that has been replaced. The solenoid bank itself was cleaned out, and several of the solenoids were replaced. About half of them were replaced, half of them did not need replacement. They were still in great shape, but the actual bank itself was dirty and was cleaned in our ultrasonic tanks and works fine now. It was the manifold that was really treated and cleaned up appropriately. From here, I also see all of the Bimba cylinders that operate the air knives. Those were all replaced, as well as the drive chains that are associated with the Bimba cylinders. Those were also replaced. We have a blower that is built onto the plenum back here. This blower was replaced. It was an item that needed to be inspected and cleaned, but in the end, a replacement was required. Coming down here, I can see that we have a heater and another blower. We're actually going to discuss that from the front when we can view them together. We also detected the tested out the motor contactors. Those were operating fine. And then we have the DI water heater that is internal to the system. This DI water heater was inspected, cleaned out, and operates great. Associated with all of these items, there's a variety of temperature sensors, overtemp switches, pressure switches. All of those on the system were replaced. So all of the sensor items were replaced with a part from Scitech. Whether new or refurbished depends on its availability on the market, and always using new when we have the option to. So now we are going to come down to the main chassis of the tool here. First, we have a wash pump. This wash pump was replaced. It was actually an identical wash pump to one that is used on another box washer by our customer. It has some slight modifications. One is that there's a water recirc feature here that was drilled in. This was a feature that was included on an older design of this pump. The newer design didn't, but can be adapted to it. This is a discussion with the manufacturer, and so that's been included. We also did a slight modification to this top sort of like a diverting union. This piece had to be modified, and actually I believe it was these pieces that were modified, each one here, because with the new pump there was a slightly different height, and it caused an unnecessary bend on these fittings in the piping. So those adjustments were made, and now this is aligned properly, as you can see here. This is our main air blower. This was fully rebuilt and cleaned out. So this was refurbished by Cytec. Inside here we have the HEPA filter, the pre-filter, and the air heater. The air heater was ohmed out, inspected, and cleaned up. It's in great shape now. The filters were also replaced. We have both a pre-filter and a HEPA filter. The pre-filter is going to be changed out on a more constant basis than the HEPA filter. The HEPA filter should last a few years. Now I'm going to switch over here. So now on this side, the magnet helic was replaced, as well as these sensors. As I mentioned, all the sensors were replaced. These ones were replaced with new ones. And then all of the filters were replaced. This is a slightly different configuration than is on a traditional box washer, because the filter manufacturer's replacement for the old filter is a slightly larger version. So as you can see, we had to add a little piping here and stagger the filters in order to have them all fit in there. But the flow rate, the filtration, and the operating function is going to be identical, minus this additional piping that is now included. The piping material is the same as the valve bank here. So we've mimicked the valve bank material for the piping. Okay. We'll go ahead and close up this bottom part of the chamber. A large Allen wrench for that. Okay. Now we'll come to the main chamber. So this entire door was replaced. The actual stainless steel was the shell of the door was built as new, as well as all of the Delrin pieces inside of here. There's also a thin sheet that's in between what you see here and the door. That was replaced. These windows are brand new, as well as the black housing of the windows that's found outside the system. It looks just like this housing. This housing was also replaced. These racks are Cytec's racks, so they're used for demonstration purposes. But here you can see we have 8-inch cassettes kept right here, 6-inch cassettes on that side. Inside the chamber we have these spray arms here, so you can see the one on the top and the one on the bottom here. All four of those sets of spray arms, or sorry, not the spray arms, but the hubs, the bearings, and the overlay disc, which are the pieces that wear, those were all replaced. As for the spray arms themselves, some of them were replaced, some of them were cleaned out and were in good shape. So it was really case-by-case basis on those. For the most part, those have a very great lifetime, and if they're in good shape, then there's no concern there. The ones that were replaced were ones that seemed to, it looked like at least, they might have been colliding with the rack or otherwise and had wear. So any of those that showed wear were replaced. Then we have our air knife spray nozzles here. None of this is replaced. These were all cleaned out, but these were replaced. The unions and the gaskets up to the wall to prevent leakage, all of those were replaced. It's like any gasket. After several years of operation, it's likely going to need replacement, and that was included in our refurbishment specification. In the back of the system, it's a little difficult to see, but there's an air dampener on each side. Those air dampeners were cleaned out and the gaskets were placed on them. Also inside of them, there is I'm trying to remember the exact name of it, exhaust aligner. There's Delrin exhaust aligners that keep the exhaust dampener in the center position. Those aligners were also replaced. There's a couple of them behind the dampener, and those were all replaced to keep them in the center position. Then lastly for the chamber, well, not lastly, but the whole chamber was also cleaned out, and the drain catch was replaced. So now the drain catch in the back is replaced with our version, which is has the correct hole size and is appropriate for catching any debris that might filter down through into the wash pump. Okay. Now we are going to take a look at the control screen. So this is an item that was asked to be addressed by the customer. They said that the control screen was running pretty dim. After we reviewed this control screen versus a couple other that we had in stock, it turns out that this one's actually in good shape. It was just as bright as the best one that we had, so this screen is in good shape, and it really is just the brightness of this controller model. So we left the same screen on that was originally included with the system. We didn't deem it was necessary to charge for another screen when really we weren't going to see any improvement. So wanted to address that as it was brought up by our customer throughout this process. Now we have the option to run a complete cycle, a dry only cycle, address our process timers, address our temperature settings, or go into the system menu. So I'm going to work our way up here. The system menu is the first one we're going to take a look at. Here we have manual mode, filter status, system controls, and password options. Password options is where you can change your password. I'm not going to go into that one. We have system controls here. Now the password for the system controls is a longer one. It's 4483131. 4483131. Okay, now this is a section that you're not likely going to have to make any adjustments to. These are system settings for our safety fill timer, a drain timer, and a cool down timer. These are important to leave at the factory settings as they were designed by the original manufacturer, Fluoroware, to ensure safe function of the tool. You do have the option of adjusting them if it's deemed necessary by the end user, but it's not our recommendation to do so. Now we have filter status. This password is 4321. Oh, shoot. Let's get back in here. Okay, 4321. This is where you can reset the timing or how long the filters have been used. You can see that the DI filter is supposed to be for 500 hours, air filter for 2,000 hours, and the HEPA filter for 4,000 hours. So as you can see, I was saying hundreds of hours of runtime in the beginning. This guy is set up for thousands of hours of runtime now, as you can see just the quality of this refurbishment that we've done here. But these have all been reset because the filters were replaced by us. All the filters in the system were replaced. So they've now been reset. When we received the tool, these filters were all over time and there were alarms that were popping up on the screen. So it's important to make sure if you see those alarms that you should replace those filters and reset these timers. Now we can go into manual mode. This is the same 4321 password. And for manual mode, you can individually actuate any of the features on here, whether it's the air heater, the blower, the dampeners, the door lock. I'll do an easy one right here with the door lock. I will be able to hear it lock when I click it. There we go. It's kind of a loud click right there. So this is where you can individually actuate any of the components during your maintenance or troubleshooting with the system. Okay, now we're going to come back here and we're going to now, I've already covered all the items here. We're going to go now into temp settings and process timers. In temp settings, you can set the set point of your dry temperature and your DI water temp. Both of these are currently set to 60 degrees Celsius and have an over temp alarm that's +10 on the dry and +5 on the DI water. In order to change this, we now have a password of 1234. Okay, so here now you can set the set points and save. We're going to leave it here as this is an appropriate operating temperature for the system. Now for process timers, this is similar. We have our surfactant timer, we have our wash timer, we have a mist timer, our 2 rinse timers, and our dry timer, as well as our DI heater idle timer. DI heater idle timer means if you stay idle this long, the DI heater is going to turn off. If not, the system keeps the DI water warm for use. In order to change settings, we have the same password, 1, 2, 3, 4. And here you can change any of the items. Okay, so that is going to cover our review of the system here. The system is online and ready to run right now. So what we're going to do is simply hit our complete cycle timer and allow the tool to run. Okay, so first thing that happened is the door locked. And now we're going to have several fills and washes that are going to happen. The first fill is going to have a surfactant spike that is then going to use a soapy solution to clean off all the cassettes inside the chamber. After we have the wash step, we're then going to have rinse steps. So after the wash step, the system's going to be drained out. The reservoir is going to be filled again, but there will be no surfactant. There'll be no surfactant spike. So we're going to have then several rinse steps after the wash step to ensure that we really rinse all of the remaining surfactant out of the chamber and prepare the cassettes for a normal drying process. So in this circumstance, you're not going to see the soapiness on the system here. The reason being is that we do not include surfactant with this. We just use a DI water fill in the surfactant tank to mimic the surfactant. So you're seeing it run without surfactant, but we have evaluated that process, checked, rebuilt the surfactant pump, and ensured that it is indeed spiking surfactant during all of these wash steps. Okay. So each of our program's rinse and wash steps is going to be 60 seconds. So between the fill time and the wash time of 60 seconds, we're going to be looking at about maybe 5 minutes or so of the actual washing that's going to occur at the beginning of this process cycle. So when it looks like it's sitting idle like this, it should be filling. And I come up here and I see we're actually draining right now, sorry. So anytime it's sitting idle like this, it'll be draining and misting the chamber. And then after it drains, we're then gonna refill up the reservoir and do the rinse steps. So taking a look here, yep, we are now on fill. The fill has a max fill timer of 2 minutes, and there's a sensor that will initiate the rinse cycle once it's been filled up. So if it takes over 2 minutes, you're going to get an alarm because it didn't fill in time. Usually this fill takes somewhere between 50 and 80 seconds. So we'll see how long it takes in this circumstance. It's been about actually only 30 seconds of fill so far here. Okay, so maybe I may have over approximated that. This one took about 37 seconds of fill time. So that's a normal operating range and tells us that we're getting a good DI flow to the system for this fill process. Okay, coming back to the back of the tool to see if I can feel the DI heater heating up to ensure that it is warming up, because I see on here that we have a set point of 60. We have a process value right now of 30. The system was sitting in idle for a little bit before, so it didn't actually heat up here, and then every time we bring water in, it's going to continually cool down the heater elements in the system, so that's expected. Okay. And now another item that I'm going to look for here is any leaks. So any leaks are typically going to be at the bottom of the door here. So we'll inspect on both sides to ensure we're not seeing any water coming out of the side of the chamber. Okay, and everything looks great. There are no leaks coming out of the front door. I'll come now to the back of the tool. And everything's sealed off back here, so you should not see any leaks on this end, but just to verify, I did take a look and don't see anything there. Okay, so now we're having another DI fill here. Now the fill should hit at the same time as the previous cycles. There we go. Got 25 more seconds of this rinse step. All right, everything in the chamber is looking good. Great, now we're going into another drain step here. All right here. Okay, so what I just did was actually turned up the exhaust on our sort of manual system here. We don't have the typical exhaust that you'd have in a normal wafer fab. So during the beginning of the filming, we have our exhaust spec low. I just turned it on high because that's more of a normal operating level. And we're going to be jumping into the dry steps soon here. And the system wants to be satisfied with the proper exhaust level. So I just go ahead and set that up there. Okay. So now I can see that we are starting to dry here. We have air knife zone 1 operating. Okay. Now we have air knife zone 2. Okay. I come to the back of the tool and take a look at these Bimba cylinders. Great, everything's looking good on that end too. I'm going to step around to the other side here. Okay, so everything looks to be operating properly on this. The dry temp is heating up. It'll hit our set point of 60 degrees here soon. So everything looks like we are operating correctly as expected. So what we're going to do here is pause the video. We have 28 minutes of dry time. Essentially, we're going to be cycling through the same steps over and over again. Air knife zones 1 through 7, operating one at a time, about 20 seconds or so of each time. That's an approximation. I have to see in the manual to just refresh my memory, but just pre-programmed in for each air knife step here, and we'll be good. So it'll be only a second in the video, but it'll be 25 minutes for us, and we'll come back and we'll inspect the chamber at the end of the dry cycle. We'll see you soon. And we're back. That was fast. So now we have 50 seconds remaining on our process timer here. Everything looks good. Our dry temp is at the 60-degree set point that we mentioned in the beginning of our process cycle here. And I'm taking a look inside the chamber. Everything is looking great and dry. This looks like it'll be a successful process run as expected. So what we're going to find at the end of this dry cycle is we're going to have a cool down timer. Excuse me, can't remember exactly how long it is. It's about 2 minutes. Excuse me, a little bit of hiccups there. Should be about 2 minutes, and that timer will start counting down on the screen, and then when that's complete, we're able to open the chamber. Okay. Great. Yep, it's a 2-minute cool down timer. That's going right now, and then we'll be able to inspect the chamber. And actually at the end of this video, what I'll also demonstrate too, just so we can show it works, is we're going to hit the EMO and then it'll shut down the system. I'll also open up this head casing area so we can take a look at the wiring beneath, demonstrate that it all looks great. Okay, 40 more seconds. And our dry cycle is complete. So we're going to acknowledge a successful run here. And we're going to open up the system here. Okay. Cassettes are nice and warm, completely dry here. It's good, they're quite hot actually. Nothing to burn you. I'll pull out this side here as well. Cassettes are warm and dry. And now taking a look into the chamber. Everything in the chamber is dry. I see a few water droplets left on the base of the chamber. That's as expected. With any drying application like this, your product is going to dry quicker than that, but adding some dry time if you need an ultra dry chamber is simple. Just simply add more dry time to the system and you can dry out the chamber completely as such. Okay, so that was a successful process run here. Now we'll go ahead and hit the EMO. System is now powered down, so we demonstrate that that guy works right there. Now going to come into the head casing area. Oh, there we go. So here we are. As you can see in here, all of this wiring is clean and appropriately lined up, labeled, nice and tight. I'd like to thank you for taking the time to view our video source inspection for today. Again, my name is Daniel Mullany and I filmed this inspection for SciTech Process Solutions. If you have any questions about our refurbishment process for this system or any of the other systems or parts or services that we can sell and provide, please take a look at our website at www.scitechprocess.com. That's SciTech spelled S-I-T-E-K. Or give us a call at 916 797-9000. And to reach me directly, dial extension 2201. Thank you so much and have a great day.